Hi, myself Prabhakaran from Physics Department, Hindustan College of Engineering and Technology. Today, we are going to discuss about magnetic materials and its fundamentals. Let me start the session with Albert Einstein quotes. Imagination is more important than knowledge. In the middle of difficulty lies opportunity. Let me start the session. Magnetic materials. Today we are going to discuss about the introduction towards magnetism, some of the terms and definitions in magnetism, and the origin of magnetic moment. Introduction. Magnetic materials are materials which can be made to behave as magnet. When these materials are kept in an external magnetic field, they will create a permanent magnetic moment in it. Some of them are diamagnetic, paramagnetic, ferromagnetic, antiferromagnetic, and ferrimagnetic. When an electron revolves around the positive nucleus, orbital magnetic moment arises, and due to spinning of electrons, spin magnetic moment arises. In 1845, Michael Faraday discovered that the magnetic materials can be broadly classified into three groups, namely diamagnetic, paramagnetic, ferromagnetic. Now, let me discuss some of the basic terms and definitions in magnetism. First one, magnetic field. What is magnetic field means? The space around the magnet or current carrying conductor where the magnetic effect is felt is called magnetic field. Unit is ampere per meter. The second one, magnetic lines of force. Magnetic field is assumed to consist of lines of magnetic forces. These lines of forces seems to travel externally from north to south pole of the magnet. This line of force are called magnetic lines of force. Please look at the diagram. The magnetic lines of force are ejected out from the north pole of the magnet and moving towards the south pole. The force exerted by the magnetic material are called magnetic lines of force. The third definition, magnetic flux. The total number of magnetic lines of force passing through the surface is known as magnetic flux. How many magnetic lines of force are ejected out? That measurable quantity is called magnetic flux. Its unit is Weber. The fourth definition, magnetic induction or magnetic flux density. It is the number of magnetic lines of forces passing perpendicularly through the unit area. How many magnetic lines of force are passing perpendicular through the material of unit area? That is called magnetic flux density. It is indicated by the symbol B. The unit is Weber per meter square or Tesla. 1 Weber is nothing but 10 to the power 8 magnetic lines of forces are ejected out from the north pole of the magnet. The fifth definition is magnetic field intensity. It is denoted by the symbol H. It is defined as the force experienced by a unit north pole placed at that point in a magnetic field. Its unit is ampere per meter. How much magnetic field strength has been applied? That is called magnetic field intensity or magnetic field strength. It is indicated by the symbol H. H is equal to B by mu. The sixth definition is magnetic dipoles. It is two equal and unlike poles separated by a distance. The seventh definition, dipole moment. The dipole moment is defined as the product of magnetic pole strength and length of the magnet. It is denoted by mu suffix m is equal to m into L. Unit is ampere per meter square. The eighth definition is intensity of magnetization or simply magnetization indicated by the symbol M. It is a measurable quantity. It is a measure of magnetization of a magnetized specimen. How much the material has been magnetized when it is placed in a magnetic field. That measurable quantity is called intensity of magnetization or simply magnetization. The ninth definition is magnetic susceptibility. It is indicated by the symbol chi. It is indicated by the symbol chi. It is defined as the ratio of intensity of magnetization produced to the applied magnetic field strength. So chi is equal to M divided by H. It is nothing but simply, if you want to understand what is susceptibility means, it is a measurable quantity. It is a measure of how easily the material is magnetized in response to applied magnetic field strength. Once again, I will be repeating, susceptibility is nothing but it is a measurable quantity. It is a measure of how easily the material is magnetized in response to applied magnetic field strength. That is called magnetic susceptibility. Next one, the 10th definition is Bohr magneton. The orbital magnetic moment and spin magnetic moment of an electron in an atom is expressed in terms of atomic unit called Bohr magneton. It is indicated by mu b. So mu b is equal to E h cross by 2m. The value of Bohr magneton is 9.27 into 10 to the power minus 24 ampere meter square. The next 11th definition is magnetic permeability. It is indicated by the symbol mu. It is also a measurable quantity only. It is a measure of how a magnetic field affects a material or affected by the material. Easy way of understanding permeability is nothing but it is a measurable quantity. It is a measure of how a magnetic field affects the material or affected by the material. That measurable quantity is called permeability. As per definition, if you want to define it, means magnetic induction due to magnetic field intensity H are directly proportional to each other. So B is directly proportional to H, or otherwise B is equal to mu naught H, where mu is equal to B by H. Mu naught is the permeability of free space or vacuum. Its value is 4 pi into 10 to the power minus 7 Henry per meter. So we can define permeability as the ratio of magnetic flux density and applied magnetic field strength or intensity. The next one, 12th definition is relative permeability. It is defined as the ratio between the permeability of the medium to the permeability of free space. Mu r is equal to mu by mu naught. The relation between permeability and susceptibility is, please look at the final equation, mu r is equal to 1 plus chi. This is the relation between permeability and susceptibility. The 13th definition is retentivity or remanence. When an external field is applied to a specimen, it is magnetized. When an external field is applied to a specimen, it is magnetized. And when the field is removed, it is demagnetized. But some materials do not completely demagnetize when a field is removed. There is some magnetization left out in a specimen. This residual magnetism, which is left out even after the removal of external magnetic field, is called retentivity or remanence. The next definition is coercivity. The residual magnetism can be removed completely from the material by applying a reverse magnetic field. The residual magnetism can be removed completely from the material by applying reverse magnetic field. What is the amount of magnetic field which we have applied to remove the residual magnetism? That quantity is called as the coercivity. Now let me discuss the origin of magnetic moment. The macroscopic magnetic properties of a substance are a consequence of magnetic moments associated with individual electron. So, if you considering what is the how the magnetic moments will be originated in each and every material means due to orbital motion of electron and spin motion of electron. The orbital motion of electron contributes orbital magnetic moment and the spin motion of electron contributes spin magnetic moment. There are three contributions for a magnetic dipole moment of an atom. The orbital motion of electron. It is called orbital magnetic moment. Spin motion of electron is called spin magnetic moment. The contribution from the nuclear spin also contributes magnetic moment, but it is 1000 times smaller than that of contribution by an electron, so it can be negligible. So each and every material is composed of atoms. Each and every atom has an electron. Electron has two type of motion. It will be having an orbital motion and spin motion. Electron is a charged particle. When a charged particle is moving, it is associated with magnetic field. So, due to orbital motion of electron, some magnetic moments will be created, that is called orbital magnetic moment. And at the same time, the electron is spinning about its own axis. Due to that also, it will contribute a magnetic dipole moment, that is called spin dipole moment. The equation for orbital angular momentum of an electron is given by, that is nothing but already we have discussed Bohr magneton. Due to spin motion of electron also, it will contribute, that also has been given as E by m h by 4 pi. Nuclear magnetic moment also contributes h by 2 pi amount of magnetic moment, but it is somewhat 1000 times smaller compared to magnetic moment contributed by an electron, so it can be negligible. Thank you all.